Alright, let's take a look at today's lesson. We're actually going to look at an AP problem that we had a couple years ago. It's a 2015 AB2 where we used volume and area. We're just going to mix everything up and do an AP problem with them. Alright, so let's take a look. This is a calculator problem. It says let f and g be the functions defined by, and it gives us what f is and what g is. And let R and S be the two regions enclosed by the graph of F and G shown. So here's our region right here. Find the sum of the areas of the regions of R and S. Okay, so the first thing that I would do is I would go to my calculator and I would enter F and G. So I actually want to indicate so that I remember which one I'm putting where. This one I'm going to make Y1 and this one I'm going to make Y2. Okay, just so that we will remember. All right, so let's go over to our calculator, go to our y equals, and let's input each of those in there. Alright, so we have 1 plus x plus e to the x squared minus 2x, x squared minus 2x. Okay, so that's my first one. That's my f of x. Let's go and input g of x. So that's x to the fourth. Oops, that's x. X to the fourth minus 6.5 x squared plus 6x and then plus 2. And let's double check and make sure we have it incorrectly because that's really important before we jump into the problem. Let's double check. Okay, x to the fourth minus 6x squared. Okay, looks good. Alright, so we have them in. And we really don't even know we don't know which one of these is F and which one is G, so we probably should graph it just to kind of get a feel for it. Notice on the graph they don't have any negative values, so I'm going to go to my window and adjust it, and it goes as far as 2, the x value of 2, and a y value of 4. So that's a relatively small window. I would like for my window to be, kind of close to that. So let's make like -2 is x, a max of, yeah, that's fine, like a 4. Then our y values, minimum, -2 is fine, and then a maximum, I don't know, maybe 6, so we get a good picture. So let's take a look at it. Alright, so now we can see. Let me go back and see which one is y1 and which one is y2. The blue one is y1 and the red one is y2. Okay, so on our graph over here, let's go ahead and label it so that we don't, get things mixed up. The blue one is y1, so this one right here is f of x. And this one, the red one, is y2, so the red one is g of x. Okay, so that's going to be important for us as we work through this. So we're supposed to find the sum of the areas of the regions R and S. Well, notice how, and I'll just kind of trace over this one. So this one changes places, right? Okay. Okay, well, let's try that again. Okay, so that was G, and that was F, and we just want to indicate which is which. Okay. Alright, so notice how G at first is the big one, and then it changes to the small one. So we're going to need to deal with that. Another thing we need to deal with is we don't even know what this point is. Okay, we don't know what it is, so we're going to have to go into our grapher and we're going to have to calculate that. So we're going to need to find that intersection. So let's just go ahead and do that. So we already have it graphed, so second calc, we want number 5 intersect, and it actually is right there, so enter, enter, and enter. So the intersection is given to us, and let's just go ahead and put it up here and label it. So my intersection, okay, my intersection here is, we'll call it A, and A is equal to 1.0328 blah blah blah. Okay. Alright, so we're going to store that. Let's go to a clear screen and we hit X, enter. So there's our A, and I'm actually going to store it as A. That just will help me. So let's store it as alpha A. Okay, so that's A. So when I write my integral, I can actually, since I have said that this is A and I've labeled what the value is, when I write my integral out for the areas, I'm not going to have to list this number over and over again. I'm not going to have to do that. So that's kind of it's helpful. It saves us a little bit of time. So they give us this intersecting point, that's 0, 2. And so we're going to integrate from 0 to A. And for this piece, the g of x is the big minus little, right? So, and we actually have already been told g of x is this, so we don't have to write that out again either. We can just say g of x minus f of x dx, don't forget your dx, and then plus, on the other side, we're going to start at A, and we're going to go to 2, that's our other intersecting point. And this time, f of x is the larger one, the big one, big minus little. So we want to go f of x minus g of x dx. Okay, so that's our setup. Let's go put that in our calculator. Okay, so we do math 9, and we're going to go from 0 to A. And let's see what our conversion was. Let's see, we said G is Y2. So we're going to do second calc, alpha calc Y2 minus, and then we said F is Y1. So alpha trace Y1 dx, okay, plus. Then we're going to do this again, math 9, and we're going from A, so alpha A, to 2. And here, this f of x is the y1, so we need to pull down y1, alpha trace y1, minus, and then g of x we said was y2, so we're going to pull down y2, and that's dx, and that gives us our answer. Okay, so let's talk about how this was scored. Okay, so we have our answer. We'd write our answer 2.004. Okay, so the scoring on part A is that students got 1 point for these limits, just writing these limits out. Either you wrote the number 1.0328 or 1.032 or 1.033, or you did something like I did and you assigned it a variable and wrote it like this. So just writing these was 1 point. Then they assigned 2 points for the integrands, so getting this with the right integrand, that's 1 point. So let's just write down the points right here, what we got going on. So the combination of these two was worth a point. And then this integrand was worth a point, and this one was worth a point. And then the answer was worth the 4th point. Part A was worth 4 points on the 2015 AB2. Okay, so let's go to part B. And what we have is region S is the base of a solid whose cross sections perpendicular to the x-axis are squares. Find the volume of the solid. Okay, so this was the first kind of volume that we did, the cross-section ones. Remember that? So the cross-sections, we are perpendicular to the x-axis. Okay, that means our integral needs to be with x's. And it's region S. So let's focus on this region over here. So S. And we're perpendicular to the x-axis. So this is where our, and it's a square. This is where our square is going to sit, right here. One side of the square is going to be right here. All right, so let's figure this out. We know the area for a squared is side squared. Now we need to figure out what would we make the side. Okay, the side would be this, right? This would be the side from here to here. And again, it's hopefully becoming a little bit more natural. Big minus little, right? We're going to take the big, which is f of x, minus little. So my side is big, which is f of x, minus little, which is g of x. Okay, so that's what we have going on. That's our side. And so to set up our area, we have area side squared. So to do our volume is going to be the integral of the area, right? We want to integrate. We want to integrate from here to here. We're doing this. This is our cross section from A to 2. And we've already said what A is, so we don't have to say it again. We're going from A to 2. And our side was f of x minus g of x, so we would have f of x minus g of x squared. Okay, so let's go over to our calculator and let's go ahead and enter all that in. So we do, let's kind of clear that so we can get a little bit higher. So we do math 9, and we're going to go from A to 2. Okay, we need a parentheses, so let's remind ourselves f of x, we put in y1, so alpha trace y1, minus g of x, we put in y2, so alpha trace y2, and then close that off and square it. So now I have the f of x minus g of x squared dx, and that gives us our answer of 1.283. So our answer is going to be 1.283. So that's part B. Let's talk about that scoring. They actually gave 2 points for the integrand. So I didn't score this one, so I'm assuming probably 1 point for the f minus g and 1 point for actually having it squared. So those were our 2 points for the integrand. And then there was 1 point for the answer. So 1 and 1, and I'm just guessing how they split the points. I don't know. That may be a split. But at any rate, 2 points for the integrand and 1 point for the answer. So that's a 3-point part. Okay. So the last part, part C, is on the next slide. So let's clear this out and go over there. Okay, it's the same prompt. Same prompt. So again, this is just the same thing that we had on the other page. Same figure. It says, let h be the vertical distance between the graphs of f and g in region S. Okay, so let's kind of get our minds wrapped around what they're talking about. So h is the vertical distance between graphs f and g. Okay, so that's h. Alright, so we have h in region S. Find the rate at which h changes with respect to x when x is 1.8. Okay, so let's back up. H is the vertical distance. So we have that drawn. We need to define it. We need to write out what h is. H is the vertical distance. Okay, this distance we could get with, yes, you guessed it, big minus little. Big minus little. And if you recall the big, that was f of x. So h is f of x minus little, which is g of x. So that's what h is. We need to define it. Great. This first sentence is taken care of. H is the vertical distance between graphs f and g in region S. All right. Now they want us to find the rate at which h changes with respect to x. So dh dx equals question mark when x equals 1.8. Ooh, that sounds familiar, right? Look how they kind of slid in a little bit of a related rates type problem in an area and volume problem. Isn't that fantastic? Okay, so what do we need to do? We need dh dx, which really, luckily it's not dh dt, right? That would be a little difficult. I mean, we've got some crazy looking graphs right here, and we're in the calculator portion, so they wanted dh dx. Basically, we just need to use the calculator to find this derivative, to find this particular derivative. That's what we need to do. And we need the derivative at 1.8. So what we need to do is we need to say we're going to find h prime of x at x equals 1.8. I mean, I'm showing you the work that you would need to show. You need to show that that's what you're doing. So now let's go to the calculator and let's do that. Alright, so, okay. So we need math 8. And let's think about this. F, if you recall, we put that in, that was y1, wasn't it? F and y1 and g and y2. So we need to pull down alpha calc y1 minus alpha calc y2. And we need that at 1.8. That's where we need it at 1.8. So we enter that, and we get, so that's going to give us a negative 3.8117. Or you can round it to, you could either put that or negative 3.812 is fine. Or 11. Those are both fine. So let's talk about what the points were here. There were 2 points for this part C. One point was just for, having defined h and considered h prime. You didn't have to get the right answer. If you just wrote out what h was and wrote h prime equals something, you would have gotten a point. And the second point had to do with the actual answer. So for this, it was considering h prime. Of course, you would have had to define what h is. And then the point was for that value. And that's basically how that problem, how we would work that problem. Okay? Any questions? All right.